Hello friends, in this video I'd like to solve the following functional equation from the Irish Mathematical Olympiad 2002, problem number 8. We wish to find all functions f from the set of rational numbers to itself such that the following functional equation f of x plus f of y equals y plus f of x is true for all x, y which are rational numbers. So my hint for this problem, there is a well-known property. First of all, there is something which is called Cauchy's functional equation, and there is a nice result about this type of equation, namely, given that some function f, which goes from the set of rational numbers into the set of real numbers, if this function satisfies so-called Cauchy's functional equation, which is f of x plus y equals f of x plus f of y for every rational arguments x and y, then f must be a linear function, i.e. f of x must be equal a times x. I mean linear, not in the higher mathematics sense. It's x times some constant. It's linear, not affine function. Okay. It is well known. You can find it on Wikipedia and other sources. I think that it's known for every person who is preparing for some types of functional equation problems for mathematical Olympiads. And so it should be possible to transform our functional equation exactly into this form of Cauchy equation. So try it yourself and I will see you in a minute. Okay, so I hope that you tried your best. My solution goes like that. So first of all, let's plug in x equals 0. So for x equals 0, what do we get? We get the following. f of y equals y plus f of 0. Okay. And from that equation, we see the following, namely, the right-hand side is injective. This function is injective. It's injective because it's an affine function. So there is no known fact that if we compose two functions, and if this composition is injective, then the inner function must be injective as well. So maybe I will write it like that. If G composed with F is injective, that implies that F must be injective. Okay, so we know that our function F is injective. Our function F must be injective. Okay, very nice. And now let's furthermore plug y equals 0. Y equals 0. What happens then? Well, if y equals 0, we have f of 0 equals f of 0. And because our function is injective, we can get rid of the outer occurrences of function f, and we know by injectivity that f of 0 must be equal to 0. Okay, so we know something. And that means, let's denote this equation by asterisk. Then our equation asterisks become f of y equals y for every rational number y. Okay. So function f is so-called, it's involution, I believe. If f composed with itself is identity, these types of functions are called involutions. Okay, so we know something now. So let's take our original equation once again. Our original equation was f of x plus f of y equals y plus f of x. And now let's do the following. Instead of x, let's put f of x, because our equation is satisfied for every rational x and y. So it should be also true after changing x and putting f of x in its place. So we have now the following: f of x plus f of y equals y plus f of x. But now, by our equation asterisk, we know that f of x is just x. Okay, and now let's take f on both sides. So I just put f on both sides. And now let's look here. Here we have f composed with itself, and again by our condition, which I marked asterisk, we know that it's just f of x plus f of y equals f of x plus y. Lo and behold, this is exactly Cauchy's functional equation. Exactly. And we know that, so that's right, it's Cauchy functional equation. And we know that implies, by well-known result, which I explained at the beginning of my reasoning, we know that f must be linear, i.e. f of x must be equal a times x for some constant a, and for every rational for every rational x. Now it's very difficult, it cannot be omitted. We need to verify this result. So we need to take our original functional equation and put this formula and see if it is satisfied. So let's do it exactly that. So verification step. So let's take the left hand side. So on the left hand side we had f of x plus f of y. So it's f of x plus a times y. So it's a times x plus ay. So it's ax plus a squared y. Okay, and the right hand side was just y plus f of x. So that's just ax plus y. And these sides should be equal for every x and y. So if this should be equal for every x and y, there are only three possibilities. Either two to be exact. Either a equals 1, because then we have x plus y, x plus y, or a equals minus 1, because then here we have minus x plus y, and here we also have minus x plus y. So our functional equation has exactly two solutions. Namely, f of x equals minus x, or f of x equals x. And that concludes our problem, our solution. So we have used various facts about functions. We have noticed injectivity. We have used Cauchy's functional equation. We have noticed that our function was involution. We have verified our results, and we have established that only two functions satisfy our equation. Very well. Thank you for watching, and see you next time. Goodbye.